So guys, we talked about in the last videos on enthalpy, and just a little reminder that heat may be also calculated at constant volume. Makes a lot of sense. Imagine this little thermal, it's closed, let's say there's no exchange with the atmosphere, and you have a closed system here. The main difference from the open system is that the open system is constant pressure because the atmosphere is pushing the system. And you know the atmosphere is of course 1 atmosphere of pressure. And in this case we're going to have different pressures because, well, you're going to evaporate and increase the pressure on the same system and so on. So it's similar case, but now it's going to be constant volume. And I just wanted to tell you right now, we're going to of course do a lot of exercise later, but for the moment let's say that you may calculate the heat, or the heat that you add here is the mass times this calorific value, let's call it CV, times the change on temperature. And this is actually the change on temperature. And you're going to see later that CV and CP in gases are not always the same, of course, because of course you're an open system, closed system, they're not the same. In general rule, CP and CV for solids and liquids, it's okay to take them as equal, but for gases, no. Okay, and it makes a lot of sense because here the same gas is going to be, well, increasing the pressure, whereas in the, where is it? In this case, if you evaporate something, well, it's going to go out and the pressure is going to remain the same. So this is constant pressure. This will be constant volume, but not constant pressure. Okay, so that's why you're going to have differences on the specific heat at constant volume and constant pressure. Okay, so once again, CV, CP for solid and liquids might be taken as the same. CV and CP for gases may not be taken as equals. Actually, later in the first law, we're going to make the first law for open systems and closed systems. We're going to see that for a closed system, the heat at constant volume will be this one, and the heat at constant pressure will be this one right here. So just let me give you another small introduction. Internal energy change is this one. M is of course mass. The change in temperature, you know it by far. And the only thing that is changing right now is that we're working with a closed system which has a closed or a volume which is constant, and you're going to calculate the specific heat capacity at constant volume. Okay, essentially is everything I wanted to show you. We're going to work with this a lot in the first law of thermodynamics, so this is a good intro before going directly to the first law.